All right, welcome back, crew. What's good in the hood? Let's get started. So, this is our first practice EKG. We're going to go through it systematically. All right, starting with our rate quickly. Remember how to calculate rate. You can look at the number of boxes or simply count the QRS complexes. I'm going to switch to black. So I'm going to use the counting method. 1, 2, 3, 4, and 5. So 5 times 6 would be 30. So we have 30 beats per minute. And this is defined as bradycardia. Next, we have our rhythm. So looking to see if it's regular or irregular. It looks pretty regular to me. So we have a regular rhythm. Wide or narrow? It is narrow. P-wave morphology. Okay, this is interesting. This is where it gets interesting. So if we look at lead 2, right, so reflexively we should always look at lead 2 for our P waves. This would be a T wave. And then this would be a P wave. Looks like there's a P wave here, 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 P wave here. Let's look at our long lead precordial V6, which is at the bottom. P here, P here, P here, P here. This looks like the P waves are kind of beating at the march of their own drum, while clearly the QRS complexes are not in sync. So there is clear AV dissociation. And we discovered this with just looking at our P-wave morphology. So we discovered what looks like to be third degree or complete heart block. So we have a third degree AV block. Next, the overall morphology though of the P waves look normal. So that's normal P wave morphology. Let's look at other blocks present. We look at V1 for right bundle, don't see the rabbit ears. We look at V5, V6 for the left bundle, don't see that. You're also not going to typically see a left bundle that has a narrow complex. We also can look at our fascicular blocks, no Q waves in leads 3 or 1, so that would be no and no. QT interval for completeness sake. There's a T wave here. Clearly that's less than half of the R to R, so that would be normal. PVCs, PACs, don't see any. Next, let's move on to access. Axis, we see in lead 1 is positive. Let's go to lead AVF. We see lead AVF is also positive. So we have normal access. Let's look at hypertrophy. Starting with our right atrium, again, we said the P wave looks, well, it could be a little bit tinted actually there. Yeah, these P waves are, they look significantly larger in lead 2 than the other leads, so I'd be tempted to call this some right atrial enlargement. In lead V1, yeah, I mean it's hard to tell. It's supposed to be. I'm not going to call that left atrial enlargement. So I think it's borderline. It could go kind of both ways. Maybe a little bit of right atrial, arguably maybe some left atrial enlargement. I'm looking at lead V1 for that left atrial enlargement. I'm not convinced. Moving on, looking for right ventricular enlargement, we also look at V1. We expect to see an R wave greater than an S wave. We do not see that. There is no R wave in lead V1. And then finally, we look at the left ventricle, and clearly the S wave in V1 and the R wave in V5 are not kissing. Okay. So we'll call it some potential right atrial enlargement. Um, and then moving on to ischemia, we'll look at the ST segments. Overall, I'm not seeing any shifts really that jump out to me. Um, there could be some slight depression, maybe. I'm not super convinced on that. Um, yeah, I'll say that that's normal. Q waves, we see a Q in, what is that? Is that V1? Excuse me, that's a P, isn't it? That is a P. It's not a Q. I was looking down here, so. Oh, that's an R prime. Not convinced on the Q waves. T wave morphology looks normal. So overall, we have a third-degree heart block, or complete heart block with with bradycardia with 30 beats per minute, potentially some right atrial enlargement, and this patient is going to need a pacemaker. All right, fun stuff. Moving on to our second example here, following our same systematic approach. Number one, let's look at the rate. All right, I see. We'll use the QRS method, obviously, in the box method because there's an irregular strip. So there are 23 complexes. It's 23 times 6. I think the rate is about 160 beats per minute. The rhythm is clearly irregular. Complexes are narrow. P-wave morphology, let's always reflex to lead 2. This is interesting. We see multiple morphologies of P waves in lead 2. So that's a P wave, that's a P wave, it's a P wave, that's a P wave. That's tinting of the P and the T. So multiple morphologies of the P waves. I am suspicious for multifocal atrial tachycardia. This would also be called wandering atrial pacemaker if the patient was not tachycardic. So if the patient had a heart rate of 100 or less, the same with ectopic atrial beats, meaning multiple P-wave morphologies but under 100 beats per minute, this would be considered wandering atrial pacemaker. So same thing as the multifocal atrial tachycardia. However, the distinction again is just the heart rate. So the heart rate's fast, we're tachycardic, and there's multiple P waves morphologies. So there are multiple foci in the heart. Love drawing hearts like this. So this is the right atrium, of course. SA node sits right there. Normally the impulse will go down directly to the AV, but clearly there's multiple signals coming in, so we know there's multiple ectopic foci going off all down towards this node. And the reason why we know they're going towards the AV node, oh, and this one's negative, but for the most part, they're positive, right? So if any electrical charge that's going towards a lead would be positive. Okay, so anyways, moving on to blocks. So right bundle, I do see a right bundle branch block in lead V1. Okay, let's look for our left bundle. Don't see that. We look at lead V5, V6. Typically, you would expect a wide QRS. I'm not seeing that. Q waves in lead 1 and S in lead 3. That could be a Q wave. That really could be a Q wave. I'm going to go ahead and call that a Q wave. And then we do see an S in in lead 3. So I'm going to go ahead and say that that is indicative of a left anterior fascicular block. So we would say these two blocks together would equal a bivesicular block. All right, looking at our QT interval, it's tough because it's the patient is tachycardic, but I'm not convinced that it is. Oh, here's a good one down here. I'm not extremely convinced. Maybe here's another good one. Borderline QT, but not convinced. Don't see any PVCs or PACs that I can see. PVCs, of course, would be wide, complex beat. There might be one. You could make the argument that's one right there. Yeah, not really seeing any other abnormal random beats. Let's look at our axis. Lead reflex to lead 1. Lead 1 looks pretty isoelectric, so if this is 1, we know that the vector is either going here or here, because that's 90 degrees from lead 1. Let's look at lead AVF. AVF, we see more of a negative, so this would be going away from lead AVF, which is here, of course. So again, it's pretty equivocal in lead 1, so we know that it's kind of perpendicular to that. And then if we look at AVF, we see that it is more negative, so it's going away from AVF. So we know we're somewhere in this range. It could be here, could be here, but nonetheless, this is going to be left axis deviation or extreme right axis deviation, one of the two. We'll call it left for now. Hypertrophy. Okay, let's look to see lead 2, of course, our P waves. Could be some right atrial enlargement. Again, it's hard to tell because it is it's multiple foci going off, so not quite as reliable. Let's see here in lead V1 that I'm looking at now. Yeah, I'm not convinced that there's any atrial enlargement. Looking for right ventricular enlargement going to V1, you would expect a larger R than S. It's about equivocal, so I'm not going to call that, but there's an argument to be had there. Finally, left ventricular enlargement, looking at the S in V1 and the R in V5, V6, clearly does not meet the 36-point criteria. So not convinced there's any hypertrophy here. Moving on to ST segment changes. Let's see. Starting in lead 1, lead 2, I don't see really strong evidence for ST segment changes. Yeah, I mean, potentially some depression going on, but nothing that is jumping out to me. Looking at for Q waves, as we said, there's a tiny Q in lead 1. This goes in line more with the left anterior fascicular block. So I'm not convinced there's evidence of infarction here just yet. And then finally, T-wave morphology looks normal for the T-waves that actually come through, and you can see. All right, so for this EKG, I'm going to go ahead and call this multifocal atrial tachycardia with a right bundle branch block and a left anterior fascicular block, or multifocal atrial tachycardia with a bifascicular block.